Hello everyone. What we see here, we see graph of x of t, and as you can see that we have two different segments. This is actually first segment between 0 and 5 seconds, and the second segment between 5 and 20 seconds. And slope here actually is a velocity of the first segment, and the slope of the second segment is actually velocity of the second segment. Let's go look over the questions. First part, find velocity for each segment. Then we need to draw graph of v of t. Third part, find function of x of t, which means mathematical expression for linear functions of x of t for each segment. And last part, we need to calculate or find average velocity between initial time of 0 seconds and final time of 10 seconds. And we need also add or show this average velocity in the graphs of x of t and v of t. Okay, now let's try to calculate the velocity of the first segment. We're going to use this formula. Okay, the first segment is between 0 and 5 seconds. We're going to use this coordinate and this coordinate to calculate the slope or velocity. Okay, final position 0, initial position minus 10 meters, as you can see here, divided by interval of time, 5 minus 0. Okay, and finally we see that constant velocity of first segment equals to 2 meters per second. Now let's calculate constant velocity of the second segment. We're going to use this coordinate and this coordinate. Okay, final position is minus 10, initial position 0, and interval of time will be 20 minus 5. Okay, as you can see here. Okay, and finally we see that constant velocity for the second segment equals minus 2/3 meters per second. Okay, next part, we need to add function graph of v of t. Okay, in first segment we calculated and found and calculated that velocity equals to 2 meters per second, and constant velocity of the second segment was minus 2/3 meters per second. Okay. Third part, we need to find linear functions of position. Okay, we're going to use this formula. Okay, we know that velocity of the first segment is 2 meters per second, and I know from the graph that when t equals 0 second, the position is minus 10. And finally, we get this expression for position of the object with respect to time, which is of course a linear function, minus 10 plus 2 times t. Okay, the same way we're calculating the linear function of the second segment. Okay, if we go look the position at time of 5, the position is 0, as you can see here. When time t equals 5 seconds, the position is 0. And velocity, of course, is minus 2/3. And finally, this is the expression of the position of the object of the second segment. Okay. And finally, we need to calculate average velocity between 0 and 10 seconds. Again, I'm going to use two methods. First, we're going to find um, displacement delta x, okay, between those two times. And of course I'm going to use linear functions of x of t. Now, when we are talking about initial time, okay, we need to understand that actually we need to use x of t of the first segment, and we're going to substitute this time of t with 0 seconds. That's why we have this value or initial position of the object at this time. The same when we are going to calculate the final position, okay, when time equals to 10 seconds. So we're going to use this linear function of position, and we're going to substitute time t with value of 10 seconds. And finally, we see that the final position is minus 10 divided by 3 meters. Now, finally, we can calculate our average velocity. Okay, we're gonna take the final position minus initial position divided by interval of time, when final time is 10 seconds, initial time is 0 seconds. Okay, you can go over the mathematical steps, and finally we see that average velocity is 2/3 meters per second. This was a first method. Now let's go look and try to find average velocity with the second method. We're going to use graph of v of t. As I explained before in previous videos, the area under v of t is actually displacement. Now we need to calculate area, this area and this area, okay? And when we add delta x1 plus delta x2, it will give us this result, delta x, displacement. Okay, now delta x1 is the base, 5 seconds, times height, 2 seconds, plus second area. The base is 10 minus 5, as you can see here, times minus 2/3. And finally, this is our displacement. And eventually we can calculate the average velocity. We're gonna take this and substitute this parameter, delta x, and divide it by interval of time, and finally we get the same result for the average speed, velocity, not speed. Okay, now we need to add this average velocity in the graph of x of t and v of t. Again, as I explained before, all you need to do, you need to look at initial position and final position and just draw the straight line between those 2 points, and this is your actually average velocity. You also can check it by, you can calculate it again. This is your delta x, this is your delta t. When you divide delta x by delta t, you'll get that the slope, okay, is actually 2/3. Now, what about v of t? This is actually the constant velocity, okay, between 0 and 10 seconds, which is actually looks like this. And also you can check that the area, this area, okay, equals to this area, the displacement. And actually that's it. Okay, I'm gonna see you or hear you in the next videos. Thank you very much.